Welcome everyone. My name is François Pierre. I'm from the company Intupix, and I want to talk to you today about the JPEG XS and how it can help reduce your carbon footprint and make your IP network sustainable. Is it good? Okay. So let's get started. What I will call sustainable goals is what is defined by the UN as reducing your impact on your environment. So the 4 focused areas are reducing your carbon footprint, trying to be efficient in saving your energy, reduce your waste, and have sustainable resources. So resources you can reuse as much as you can. In the context of the media industry, I would say there's different options, but the main three is to adopt green practices, try to reduce your emission, and promote awareness. So JPEG XS will not apply everywhere there, but we'll get there. The good thing is all those options sometimes can also help reduce your costs, so you win on both sides. So in live TV production, how can you reduce your carbon footprint? Basically reusing renewable energy, LED lighting that save powers, energy efficient equipment. This is some place where JPEG XS can have a role, the third one. Remote production, that means fewer travel, less planes, less trucks, less duplication of equipment. So that also save your carbon footprint, and that reduces emissions. Sustainable set design. That means you try not to get rid of your equipment after you use it. Try to reuse it as much as you can and minimize your waste. And fourth point, that could be having an eco-friendly broadcasting. So cloud-based network, for example, you save on consumption, but you can also share the resources when you don't use it with other people. So JPEG XS, for those who are not familiar, is a codec, but it's a codec that's dedicated for people that are used to uncompress and don't want to hear about compression. But at some point they have an issue, they don't have enough bandwidth. So you will use JPEG XS when you did that little bit of compression to fit in your network, and you don't have all the disadvantages of big compressions that you can go if you use other codecs. So what I mean by that is, compared to uncompressed, well, we preserve the same quality. We preserve the quality, but we can do it also over multiple compressions. That's what I mean by constant quality. You will stay at the same level of quality. The next 3 points are all together a nice feature of it because it's low complexity. That means it saves power. It doesn't require a lot of processing. It's highly parallelizable. That means you can run it on any kinds of platform, software or hardware. FPGA, ASICs for hardware, CPU, GPU in software. And because it's low complexity, it's also very fast. So the latency it introduces, you can count it in terms of video lines. So in total, 32 video lines, that's less than 1 millisecond. So you really don't perceive it. And this codec is wavelet based. So that means you have a lot of wavelet advantages that gives you a lot of scalability. You can have a proxy that's actually embedded in the codec and doesn't require extra processing. So from a compressed stream, you can extract a small proxy features without doing much effort. And last, it's also open specification. It's a standard. So it allows interoperability. And in the creation of the standard, it's future-proof for many resolution, 4K, 8K, lots of different formats and colors. So why are we talking about codecs and sustainability? Well, the way the codec was designed was really to minimize complexity, power consumption, and create an algorithm that works very well on any kind of platform. That's really a codec that's designed to be transparent. And that also applies in terms of energy consumption. So using the codecs, you use less computing power than when you try to transmit a lot of data. You use less memory. Overall, you reduce your footprint. And because it's also light and low complexity, it works very well in remote applications. And remote application, as I mentioned in the first slides, is a way also to reduce your footprint. Overall, it's aligned with what we call the 3 R's: reduce, reuse, and recycle. So reduce is you use less, in this case, bandwidth, energy. Reuse is try to make your infrastructure more sustainable, give it another life by introducing the codec. You can reuse an existing infrastructure for other purpose. And in the term of recycle, in this case, it's a bit similar, but you don't need additional hardware to support JPEG XS. If you already have, let's say, a server with an FPGA inside, you can put the compression inside the FPGA and reuse your existing equipment. So when I mean that JPEG XS is not really a codec, it's because it's more a replacement of network flows where you have uncompressed. If you're familiar with MPEG codecs, HEVC, H.264, you have a very high compression ratio. You don't get it with JPEG XS, but you have all the other advantages that are not there in this complex codec. It's low latency. It's high quality, so it's very similar to the quality you have in uncompressed. It works on any platform, and the complexity is very low. And as you see, I mentioned here 2 profiles. So they're both JPEG XS. JPEG XS high profile is the one that's currently used widely already in the broadcast industry, and it's been released since 2019. And the TDC profile is a latest release of the codec, so it's an improvement in terms of compression ratio with a little bit more complexity. Now, this is all theoretical, but let's get into actual applications where we could see that JPEG XS is improving in terms of carbon footprints. So in Topics ourselves, we don't use JPEG XS in our daily life, but we have customers that integrate the JPEG XS and have experiences with it that shows that they can save on their environmental goals. First example is a Chinese media group. They did a live broadcast of archaeological program. So there was some diggings, and during this live transmission, they used JPEG XS straight from a Grass Valley camera, and that went directly into a software-based one, and they achieved the same quality as they would have with a much bigger infrastructure, without having to move a lot of equipment on site, and using existing infrastructure to leverage the broadcast quality, and that's all using JPEG XS from the camera to up to the distribution. Second example is VR systems. So that's something that's very used in soccer now. And that's basically a force referee that's not on site, but that can watch all the parts of the game remotely and assess if there's a fault, if there's something, if there's a real goal. And basically, normally, this type of equipment is really next to the stadium. But using JPEG XS, you have applications where you can do it remotely. And because of the low latency of JPEG XS, you can do it live, and you don't interrupt the game because of the latency of the transmission back and forth. when I say you can reuse the infrastructure, it's true that we have some customers that integrated JPEG XS in existing equipment. If they have an FPGA, it's a reprogrammable device. You can, without changing your hardware, reprogram it to do a new functions, and you can introduce the compression inside. And legacy compression was, for example, JPEG 2000, which is a very good codec, but it's a bit complex. It's only runs in the FPGA. In software, it's very hard to integrate. And it's big. If you put JPEG XS instead, you save a lot of size in your FPGA. So you're 2 times to 4 times smaller. That allows you to do maybe more channels in the same component. You don't need an external memory or very little of it. An external memory, it's power consuming to access to the memory back and forth. So you're really saving here actual energy. And overall, you save a lot of power because you don't use the DDR, because you can put more channel in the same device. So in this example, the company is Megalinks, and they replace their whole infrastructure overall the United States, took JPEG XS out of their box, reprogrammed the FPGA, put JPEG XS inside, and that's about 1,000 equipments that were upgraded to JPEG XS just by changing the firmware. So no hardware, actual unplugging or anything else. And if you want to go into details, so they managed to reduce overall by 20 watts each port of video. So if you count that over 1,000 cards, that's something. They also improved a lot the latency of the overall channel, because the latency of JPEG 2000 is more in the average of 2 to 3 frames, whereas now we are at less than 1 millisecond. And it's a recycling. They use existing FPGA, existing boards. They don't have to refinance, I would say, in terms of hardware. Next example, we are now moving to the cloud, or at least we're going to go to very high resolutions, 4K, 8K. It's very expensive in terms of bandwidth. 8K, we're talking about 60 gig when it's uncompressed. And I was mentioning JPEG 2000 before. Try to do 8K in JPEG 2000. It's going to be also very heavy. Need a lot of external memory, lots of power. With JPEG XS, you can compress 8K down to 2.5 gig. And 2.5 gig is your standard Cat5e cable. So it's a much cheaper infrastructure to do the compression in this use case, because you don't need fiber, you don't need expensive switches, 25 gig or 100 gig. You can use more cuts, or at least 10 gig switches, and you can transport multiple 8K channel over that. So in this use case, Japanese company Village Islands was managed to have a full infrastructure upgraded to do 4K, 8K without any big investments that would be required if you want to go uncompressed. Cloud production, so I was a bit ahead before, but Amazon Web Service is using JPEG XS actually. And to move to the cloud and back, JPEG XS saves you a lot of bandwidth as well. And by going into the cloud, you don't need to have your infrastructure and do everything inside your building. So you save a lot of power internally. You use the cloud infrastructure only when you want. And while you don't use it, someone else can use it. So we're saving power generally, globally. And this is all using compression, because if you try to do it without compression, the bandwidth required to do all your processing back and forth is also going to be costly. What you pay to AWS is actually an amount of bandwidth for a certain amount of time, and the less you take, the less you pay. Actually, doing the compression with JPEG XS is also already power saving. If you compare it to other codecs, which are much more complex, we can run much faster, and we don't use that much power inside the CPU itself in software. So a single HD channel or one CPU core, basically. So I will conclude here by saying that even though it's hard to measure, we had a few concrete examples here that were shown where actual infrastructure were improved in terms of power consumption and cost by using JPEG XS compression. So this is possible because of the low latency, low complexity of the compression. You can also save by reusing your infrastructure. It has been proven in actual events. And in terms of sustainability, we have some equipment that was supposed to be updated or upgraded to new boards that can be reused using the technology. So now that you are at NAB, you can see JPEG XS in a lot of booths. Actually, there's more than 150 products around, 75 vendors using it. You're welcome to take the list, or I can talk to you after the presentation if you want to know more about vendors that already have JPEG XS products. And that concludes my presentation. If you have any question. So gentleman was asking, how do you transport JPEG XS? There's actually different ways. The most widely known right now, as the most popular, is using 2110. So that's full IP. And you can go to the Ames booth to know more about that. It's just behind the theater. But you can also actually do TR-7. So you can use 2022. That's IP based, but that's all essence all together like you would have on an SDI cable. And there's actually people doing JPEG XS over SDI cable. Now in the cloud, well, we have software solution. You can use an SDK from a third-party vendor as well that connects you to the cloud, and then you within the cloud. That's a question for AWS or other people doing clouds. Not that familiar, but it really depends on what's running on the cloud. And okay, thank you.